Okay. So we said there were 3 ways to analyze limits. They were numerically, algebraically, and last one is from graphs. So remember that with limits, the question revolves around whether or not the sequence or function is getting close to a specific number. It doesn't actually have to get to that number. Sometimes it does, as we'll see in a few of these graphical examples, but it doesn't have to. It just has to get close to that number from both sides, or if we're just looking at the left or just looking at the right. So let's try a few of them. So this one is looking at the limit as x approaches 2. Now, since it doesn't have the plus or the minus to the above and to the right of the 2, it means from both sides. So I want to look at as x gets closer and closer to 2 from the left, what are my y values doing? They're getting closer and closer to the value, looks like 1, right? So the limit as x approaches 2 from the left of our function is 1. And then what happens as we approach from the right? So as I get closer and closer to 2 from the right-hand side, what happens to my y values? They're getting closer and closer to 1. So the limit as x approaches 2 from the right is also 1. So since these are the same, this implies that the limit as x approaches 2 of our function is 1, and that would be our final answer. Okay, so we want to check that they're the same from the left and the right when we're looking for the limit. Okay. Let's try a couple more. Again, this is looking at this almost the exact same function, except it's got 1 point removed and placed somewhere else. So we have to ask ourselves, does that really make a difference? So again, we want to check from the left. Okay, as we saw, as we come from the left, we're approaching and getting closer and closer to 1. So this limit as x approaches 2 from the left is 1. Okay, remember, it just needs to get close to. We don't actually have to get there. And from the right, it's also getting closer and closer to 1. So the limit as x approaches 2 from the right of our function is also 1. Doesn't matter that the function value, note that f of 2 is equal to 4. We don't care. We want to know the limit. What are we getting closer and closer to? Okay, you don't actually have to reach there. If you think about the idea of you have a friend, and the two of you are make an appointment to meet at a diner for lunch. And the both of you drive from your respective homes, and you're each getting closer and closer from the 2 different sides of the diner, and you do eventually get there, and you discover that the diner is gone. There's a big hole in the ground. There was a big fire, explosion, whatever. Even though the diner is gone, you both arrived there. You got close to where the diner used to be, right? So you still arrived at the same sort of destination, even though the diner wasn't there. That's the sort of idea. And even though there's a hole in the graph where the point has been moved, you're still able to get sufficiently close to that point. Okay. Let's take a look at this one on the bottom left here. Again, this is still looking at x approaches 2 from both the right and the left at the same time. And we run into a little problem here, because as we approach 2 from the left, what's that limit? It does not exist, and in fact goes to negative infinity. And if we look at from the right, as we get close to 2 from the right, where's the right side of that function going? That limit also does not exist, and it goes to positive infinity. So for 2 reasons, this limit does not exist. First, because it grows without bound in either the positive or negative direction. In fact, they're 2 different directions, so we don't reach the same point. It's sort of like when you look at a picture of an expressway and there's an on-ramp going one direction and an on-ramp going the other direction. There's no way you can get to the same place if each of you takes those different ramps, right? So we would say here that this limit does not exist. DNE does not exist. Okay. Right. This one here in the middle, limit as x approaches 1 from the left. Okay, so the limit as x approaches 1 from the left, we see that that limit is 3. The limit as x approaches 1 from the right, that would be these function values. That is negative 3. So since they approach 2 different values, we would say, since they're not the same, aren't ending up at the same place, This last limit does not exist. Okay, let's try another. This asks us to determine whether these are true statements. Okay. The first one says the limit of f of x as x approaches 0, so that means both from the right and from the left at the same time, is -2. Let's test to see whether or not that's true or not. So if we approach 0 from the left, we get a limit of 2. And if we approach from the right, we get a limit of -2. So this one is false. This actually does not have a limit. Okay, this part A does not have a limit. The limit as x approaches 0 of f of x does not exist because we approach two different limits from the left and from the right. Okay, next one, let's see, let's go to B. Limit as x approaches 0 from the right is -2. So that was the one we did here. The limit as x approaches 2 from the right is -2. That one is true. Next one asks us, the limit as x approaches 2 of f of x is 0. Okay, let me do. So here's 2. So if we approach from the right and from the left, we get out that point is 2, 0, right? So the output is 0. So that one is true. From the limit from the left is 0, limit from the right is 0, therefore the limit is 0. Okay. Next one asks us about the limit as x approaches 3 of f of x is equal to 1. Okay. Get rid of some of my marks here. Oops, didn't want to do that. That one x approaches 2, that one was true. Okay, sorry. All right, limit as x approaches 3. So again, we're going to come from the left. So this time my arrow is going to point in that direction. And from the right. And in fact, let's see. Yep, that's at 1. So that one would also be true. Next one asks us about our function value at 3. This says f of 3 equals 4. So here's 3. What's its function value? Well, there's a hole here on that line, that straight line. So that means, well, there's no point at 3 there, but notice that it is up here. So f of 3 is in fact 4. That's true. And then our next question asks, is the limit as x approaches 3 from the left, is it equal to 3? Well, the answer is no, because we already saw that the limit as x approaches 3, which means both from the left and the right, is 1. So this answer would be false. All right. Lastly, we look at something called limits at infinity, not to infinity. So limits at infinity mean that x is going to infinity. Limits to infinity mean that our output is infinite. Okay? Our answer is infinite. So that's the difference between at infinity and to infinity. So at infinity means our x value is going to infinity. To infinity means the limit itself is infinite. The answer is infinite. So I want to know what happens to functions as x grows larger and larger. So we can take a look at this by plugging this into our calculator, doing a numerical analysis, or we can just ask ourselves, as x gets very, very large, what happens to x squared? It gets really, really large, right? 10 squared, 100 squared, 1,000 squared, 1,000,000 squared. Adding on 5 gets even larger, and then taking the square root. So this is growing without bound. In fact, if we took a look at what its graph looks like, I believe, if I'm not mistaken, this looks something like this. And you can double check that with your graphing calculator. But the idea here is as x goes to infinity, so as this gets larger and larger in the positive direction, what's happening to this graph? It's continuing to grow, not very quickly, but it is continuing to grow. It's getting larger and larger. So this limit does not exist. And in fact, because it is infinite, it goes to positive infinity. Okay. Next one here is the limit as x goes to negative infinity of 2 over x. And again, I'm going to draw a graph to help us get a visual of what this looks like. So 2 over x has 2 parts to it. It looks like so. Okay. So the limit as x goes to negative infinity, so that means in this direction. What happens to our function values? Okay. Notice they're getting smaller and smaller. They're getting closer and closer to the x-axis. Okay, even if I plug this into my graphing calculator, you can try 2 over negative 10, 2 over negative 100, 2 over negative 1,000, 2 over negative 1,000,000. You'll see that the number is getting smaller and smaller and smaller from below 0 or from the left of 0. But in fact, the idea of a limit is we're getting closer and closer and closer to that particular number. So this does have a limit. It goes to 0. Okay, and in fact, it turns out this is just another way to find horizontal asymptotes of rational functions, because in fact this has a horizontal asymptote. We can see it's the x-axis is the horizontal asymptote. What does that mean? Well, since this is the same way that we can, another way to find horizontal asymptotes, we can use those same techniques that we use to find horizontal asymptotes to find infinite limits. So let's recall that in order to find horizontal asymptotes of rational functions, so 3x over 2 minus 6x is a rational function, we said that the easiest way to do this is to go ahead and take the leading terms. So the leading term in the numerator is 3x. Leading term in the denominator is negative 6x. And if I simplify this, I get negative 1/2. And what do we say? If we got out a number, then that was the horizontal asymptote. And it's the same in the case of limits. This is, in fact, the limit for this case. Again, if you're having trouble understanding or conceptualizing this, try it out on a calculator. Put 3x over parentheses 2 minus 6x, close parentheses, and do either the trace feature on your function and let x get larger and larger and larger, or use the table feature to see what happens as x gets larger and larger and larger. You'll see it gets to negative 1/2. But this is an algebraic or sort of an analytical way to take a look at it, rather numerical. So let's try again. So we've got the next one is limit of 3x cubed over x squared minus 4 as x goes to infinity. So again, I'm going to take the leading term, which is 3x cubed over x squared, and when I simplify, I end up with 3x. What happens then to 3x as x gets very, very large? 3x gets very, very large. It's going to blow up. So as x gets huge, 3x will get huge, and so this does not have a limit. And we, in fact, know that it is an infinite limit, and that's positive. Okay. In the same way, if we did this analysis to find out if there was a horizontal asymptote, we would say no, there is not a horizontal asymptote. So the same sort of strategy applies. Okay, this next one, the limit of 3x over x squared minus 4 as x goes to infinity. Again, we take the leading terms, which are 3x over x squared, and we simplify this, and we get 3 over x. Okay, we said when we were analyzing horizontal asymptotes that if you ended up with a number over x, or you ended up with a variable in the denominator, then that the horizontal asymptote was 0, right? It was the x-axis. And we can see that as x gets very, very large, 3 over that very, very large number is going to get smaller and smaller. So again, you could analyze this numerically and see that 3x over x squared minus 4, as x gets very, very large, this is going to get smaller and smaller and smaller, and in fact, it's going to approach 0. Okay? All right, so that was our lecture on limits, our introduction to limits.